Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Multilingual. It's a medium problem. You guys can pause and go over it once. So just to explain a bit about this problem, we've got 70 members, right? And we have to come up with a particular set of languages such that we could assign the languages to all the 70 members in such a manner that for any two members x and y, there's a language that x speaks but y does not, and there's a language that y speaks but x does not. So we have a set of languages, right? And we have to distribute that set among 70 members in such a way that for each of those subsets, each of those 70 subsets, if we pick any two of those subsets, it satisfies the line given over here. And the question that we've been asked is how many languages does there have to be within this set of languages in order to satisfy this constraint? So we have to find the minimum number of languages in this given set of languages for which this case of splitting it into 70 subsets and applying this constraint on each and every pair of subsets is satisfied. Just to give you guys a bit of a push towards thinking about solutions, one answer that you might think of is to create a set of 70 languages, right? So let's say this is our set of languages and this has 70 values. And all we do is we assign one language to each of those 70 members, right? So what happens using by this is each and every person knows a unique language that which only that person knows. So this is gonna satisfy the condition over here. Since X knows his own language and Y knows his own language, it's gonna be guaranteed that X speaks a language that Y does not, and Y speaks a language that X does not. So 70 is one answer that we could come up with, but there's obviously answers that are better than this. By better, I mean values that are smaller than 70. So if you think about the problem, basically we have to create 70 unique combinations from a given set of languages with this additional constraint underlined over here, right? So try to emphasize on the point that we need to create 70 unique combinations. Now, while playing around, you start to realize that while creating a set of languages and then creating subsets from that set with this given constraint, nobody must be a subset of another person because of the given underlying constraint. To maximize the different possible subsets, and by subsets I mean members, right? So to maximize the different possible subsets possible of the given language set, it is beneficial that every subset must be of the exact same size. And if we're going to consider each of those different combinations to be of an exact same size, then we could denote the value of different combinations that are possible given our initial set to be the value NCR, right? Now, over here, N denotes the size of the language set, and R denotes the size of the particular subsets that we create from this larger set for each particular person. And the goal is to create 70 of such subsets, right? Or at least 70 subsets. Now, why do I consider the value NCR? How did NCR come into the picture? Well, NCR by definition denotes all the possible unique subsets of size R from n distinct languages. And that is exactly what we're trying to find over here. We're trying to find all the possible different subsets of a given same size, since we came to the conclusion that having all the subsets of the same size is beneficial because of the constraint given over here, right? So yeah, so to create all the possible unique subsets of a size R from a given set of n distinct languages, right? That is the initial set of languages that we have to come up with, by at least the value n, or the size of that set of languages. This NCR perfectly denotes the value. And what we're trying to figure out is basically we want to figure out the minimum value of n satisfying this equation over here. Now, according to a bit of math theory about combinations, we know that this value NCR is maximum, and I'm considering n to be constant over here so that we could figure out a conclusion about R, when R is equal to n by 2, or basically n by 2 floored, right? Because n could be odd over here, right? And since we're trying to figure out the minimum value of n satisfying this equation, it's beneficial if we set a value of R such that this value can be maximized, right? So now the new equation that we have to solve is basically this over here. And now it's just a case of trial and error. And you'll soon realize that for n greater than or equal to 8, this value, the above equation satisfies. So the answer to the problem is n equals to 8. Or basically, to answer the given question, we will need at least 8 different languages to be spoken by this group in order to create 70 unique subsets where this constraint is satisfied. I hope you guys understood the solution, and thanks for watching.